Hello, my name is Theresa Stack. I'm an associate professor at Montana Tech, and this learning unit covers industrial workstation design. Many times in our industrial workspaces, our work piece is actually our work surface. So here you see a picture of an accommodation ladder. An accommodation ladder goes with ocean-going vessels so that you can go from the ship or the boat to shore. They're rather large pieces of equipment. They're stored on the side of the ship. When they're stored flat, so the railings fold down as well as the treads fold down. One of the issues that they have with these accommodation ladders is over time, the areas in which the treads are bolted on or the handrails are bolted on become rusted, and so you can't actually open them up anymore so that they look like this. And so once a year, sailors have to perform preventative maintenance tasks on these accommodation ladders. So in the picture that you see, the accommodation ladder is just sitting on a set of workhorses. When it has to be flipped over on its side and upside down, people have to do that manually. It's not height adjustable, so it doesn't accommodate any person's actual height. And they're pretty heavy. They're around 250 to 300 pounds, depending on the length and the size of the ladder. Here's again some more pictures of the people who are working on the ladder. You can see that they lean forward. They have to use different types of hand tools to be able to take the ladder apart and replace all those different bolts for both the treads and the railing system. So the solution that the Navy put into place is one that you see here. This is where we took the workstation and we made it angularly adjustable so that it rotates 360 degrees. And this orients the work towards the worker, which is one of our workstation design principles. As well as by being able to orient it towards the worker, you can adjust it up and down slightly. And so we took our work piece and our workstation and we adjusted it in such a way that we're able to accommodate different workers. This also helped when they were doing different types of welding tasks on the accommodation ladders, because it's better to weld when the ladder's in its upright or vertical position than in its horizontal position. So this is an example of industrial workstation design, maybe not typically what you think of, but another way of looking at how we try to fit the workstation to accommodate the worker based on the task that they're performing. So our objectives for this learning unit, you should be able to recognize the best work surface height for a given task. And those questions are both on the CIH and the CSP. They ask questions about elbow height and work surface height given the type of tasks that people perform. You'll be able to interpret the appropriate work envelope that an employee can use, whether it's a seated workstation or a standing workstation. You'll understand the principles behind your different types of postures. So seated, standing, leaning, sit to stand, and how you can accommodate the worker by changing the workstation in some way, shape, or form. You should be able to demonstrate common workstation solutions. You'll do this with your assignment. And then we'll again review the general guidelines for workstation design. So let's just do a quick review of what the physical workplace risk factors are and how they're important in workstation design. So you have force, your external force when you're grabbing onto a tool, or that internal compression of your hands, your arms, your wrists, or even the stabilization of your core muscles or your back muscles. You have posture, which is really related to workstation design, because a person is going to bend their body to best fit that workstation, bend over or contort. Repetition is doing the task over and over again. A lot of times your body doesn't have a chance to heal. Vibration associated with either hand tools or whole body vibration if you're on a floor that's vibrating, for example, in power plants, or if you're on a piece of equipment that's vibrating, as opposed to single point vibration, which is the use of hand tools. Compression, that hard object pressing into your soft tissue. And duration, which modifies or extends the other physical workplace risk factors. So our goal is to try to turn these down or reduce them to the lowest amount that's feasible. And one more review slide here. Remember in anthropometry how we took a look at posture and strength. So when you're in your neutral posture, you're the strongest. And as you move through extension, flexion, radial, and ulnar deviation, your ability to be able to exert that force, whether it's the force with your hand or your shoulder holding yourself up in a certain position, or your back forces when you're lifting, they decrease as you deviate from neutral posture. So even if we're only making small changes in a workstation, we want to get people into their neutral posture as much as possible. Ears over the shoulders, shoulders over the hips, elbows are also underneath the shoulder, not flaying out like chicken arms. Hips and knees in line if you're in a standing position. Also recall from anthropometry that we try to accommodate people of different heights or different abilities by having equipment that can adjust through a range. And so we are trying to identify which percentage of the population we're accommodating or which percentage of the population we are excluding from our design. So in this picture, we have some people who are working on small aircraft parts that are sitting right on that workbench surface. We have 3 different workers there of 3 different heights. How do you think we can accommodate these workers? What would be a different solution that you may want to put into place when you're accommodating these workers? Well, maybe you could come up with some answers as we go through the PowerPoint. Sit to stand stools may be an option. Accommodating the tallest person and then having some type of platform for a shorter worker, enabling the shorter person to stand and the taller person to sit. Different height workstations, these are all ways we could have accommodated people there. So another rule when we're looking at workstation design, or really just ergonomics in general, is we want to try to accommodate 7 different working postures throughout the day if possible, to give a chance for large dynamic movements to become static movements and static movements to become large dynamic movements. So it's through this movement that our body is able to heal or recover from the fatigue of a day. So we try to permit several different working postures: sitting, standing, sit to stand, the favorite of ergonomists, leaning, and reclined postures. So here's an example of a reclined posture. The workers had to either kneel down or they would squat down in this position to work up underneath this AVA aircraft. And we were able to provide for them this industrial seating, which supports workers while they are working beneath something. So it enables them to lean back like on a mechanic creeper, but it's high enough above the ground that you can use it for things that are higher than vehicles. They do go as high, some of them go as high as 6 feet above the ground. And again, trying to support that person. So although they have to be down in a almost completely laying down type position, we can support their back on an angle and also provide a pad for them to be on, so to reduce that compression. So these angled creepers are also ways in which we can get people closer to their job, preventing the static buildup of lactic acid in the muscles, and enable them to work in a more comfortable position. Here's another example of the reclining chair. And while there are plenty of companies out there that make industrial work seat solutions for people that are in not necessarily the cleanest of jobs, but can able to take a load off and be able to lean back or recline back. This particular company does a pretty good job with a variety of options that are available to individuals and includes the tool caddies to go along with them, as you can see beneath and along the side of the industrial seating. So solutions for people who have to work hard but still have to sit. One of the downsides of sitting when you have to exert high forces is it's really hard to stabilize your torso and can put a lot of extra force on your lower back. But if you have to get beneath something and you have no other choice, it's nice to be able to be supported. This is one of the largest helicopters that the Navy Marine Corps fly. And this is called the stub wing. There's fuel that is transported in that area. And here's an example of what it looked like before when they were doing repair processes inside of the stub wing. And the solution that they were able to put into place made it easier not only to get inside, but be able to adjust the height of the workpiece, which is the workstation, to the height of any worker and greatly reduce the risk of injury. So these adjustable workhorses or workstations were made in-house for about $2,400 each, and they produced 40 of them. They can be used seated or standing and in many different situations. So some guidelines for our seated workstations. Seated is preferred if all items are within easy reach, and they're within your work zone. Or the primary task is precision. Precision work is where you have to stable your forearms and you're manipulating objects through the ends of your fingers. It's also preferred if you do not have to handle items more than 6 inches above the work surface so that your hands are there and about below shoulder height. You don't want to be having your hands up above shoulder height. From a seated position, it's really hard to stabilize your core muscles, and you don't have to engage in any large forces. So you're not kneading bread or pushing objects together, and therefore that's when a seated workstation is good. So you tried also with a seated workstation, we want to make sure that there's enough clearance for the head, the knees, and the thighs so that people can get all the way up underneath their workstation and they're not leaning forward. This happens a lot in our office environments where our chair forearm rests hit the edge of the desk and don't go underneath them, and therefore it keeps us from fully utilizing our chair. You try to match the task lighting to what's being done in that seated position, whether it's precision and you need highlight, or are you working in a computer office environment and the monitor or the screen is the light, and then you could actually decrease the ambient light. Orient objects towards the worker, that prevents that neck flexion. Always design from the working point of the hand. So when you're watching people work, where do their hands need to be positioned? Then you can adjust or select the workstation height or the fixture to best accommodate that. And in this picture, you can see there's padded edges. And that's really important when people have to stabilize their forearms so that the edge of the desk or table is not cutting into their forearms. And like we learned in upper extremity musculoskeletal disorders, your forearms, your elbows, your upper arms, your tendons, your ligaments run really close to the surface there, and it's really easy for them to be damaged by compression. So here's our before and our after pictures. Before, contact stress on the forearms and the elbows, holding the hands up above the surface and holding on to the workpiece. You can see the neck is flexed forward. And another reason that we were able to do this project is workers were exposed to all sorts of different types of chemical agents, including beryllium and some metals. This was in a dental prosthetic lab. In our after picture, you can see that the elbows are supported on a comfortable forearm rest. There's a cutout, so it's banana shaped, which means your elbows can be supported at your sides and then allow room for your torso. This is a good solution in seated workstation design, and the workpiece is oriented towards the worker. So as far as chairs go, there is a chair selection guide under office ergonomics that you can use. But you really have to think about what's the chair being used for. I mean, how many hours a day is somebody sitting? Do you have an extreme population? Is the work surface adjustable? Then the chair maybe doesn't need as much adjustability. And who does the chair fit? So does the chair fit in height, somebody who's short, but in width, somebody who's narrow, right? So you want to make sure the anthropometrics of the population fit the chair, or the chair is adjustable, or different size chairs are provided. And you have multiple users or one user. Always really think about the task and then try to match it to the job. Because, for example, if you have 24-hour users, you may need a different type of chair. And 24-hour users like dispatch offices or monitoring over at a hydroelectric plant, people, that chair may be in use 24 hours a day and will have different requirements, so it doesn't break down on you and it fits the whole population. This is a picture or an advertisement for chairs that are used in dispatch centers or 24/7 environments. You can see the high adjustability within the chair, as well as the stout design because of its long duration of use every day. If you're going to have armrests on chairs, I think they should be highly adjustable because that's what usually causes you to change your posture. If the armrest is too high, you force your shoulders up. If they're too long, it prevents you from getting close into the workstation. It's really a limiting factor in chair design is the armrest supports themselves. You would want to make sure the height is able to go down to the lowest floor to popliteal height of your population as well as the tallest. Here's an example of where your workstation is also your transportation. These were some Navy SEALs, and these craft masters would deliver the Navy people to their mission. And you can see that the chairs are actually like sit-stand chairs, so you're in almost a standing position, but you're able to sit on the chair like you were riding a horse. This is so as the boat is going through the water and it's hitting chop, and you can see that visually, you'd be able to negotiate the impact with your legs and not take all that impact in your spine. And that's how these seats were designed, as well as vibration mitigation, dampening type material on the floor. And you can see the Craftmaster seats here too are pretty well designed to provide that cushion where these folks can't actually stand up. They have to be in a seated posture, but the throttle control is right underneath their hands. So these saddle seat designs, sometimes it takes folks a little while to get used to them, but it positions the hips in such a way that it allows space for the tailbone to drop into. So in your different types of environments, this just happens to take a look at a dental clinic. Sometimes, like here, we don't have any clearance for our legs. We can't put our legs underneath the worker, and therefore we're sitting in a sideways position. And again, with the neck tilted sideways so we can see into the person's mouth. And a lot of times our workstations are our workpieces, our people, and it's harder to manipulate or find the right kinds of solutions. So, some solutions for people who are required to sit and lean forward is to have them lean against something. So, if you could support the weight of your torso, like you see here in this picture, she's leaning forward against the backrest, which isn't really the backrest, it's the forward rest. So, she's leaning against a torso support. She's taken some of that pressure off of her lower back, and by having her hips up higher than her knees, it helps to accentuate or promote the curvature in the lower back or the spine, which puts a lot less pressure on your lower back. When you have your knees and your hips at the same height or your knees higher than your hips, you automatically lose that curvature in your lower back. So having this hip higher than the knee position, even when you're sitting, promotes the neutral posture of the spine. This is a chair by Neutral Posture. I think they're called Igo Ergo too as well. It's an ab stool where you lean forward against this pad. And there's some other dental clinic-y type chairs, which you can see in this picture where you rest your forearms on it when you're doing the work. But we've also used these in aircraft repair where people were leaning forward like polishing aircraft. And this is an example of a chair which it could be used in an office environment and again get you in that saddle seat position. But what you're trying to do is position yourself first and then bring the patient to you. Position yourself, then bring the workpiece to you. So you as the worker or as you're educating your workers are in as close to a neutral position as possible. Again, your knees are lower than your hips, your hands are slightly lower than your elbows aren't winged out at the side. So, how do we design from the working point of the hands? Well, preferably in assembly areas, when we're assembling, we want to have our hands no further forward than about 5 inches. That's so your elbows can be close to your sides. Tools that are used frequently can be as far away as about 10 inches, and of course, there's an arc there that's as far forward. And tools that are used infrequently can be as far away as arm's reach if you have to deviate forward slightly. So it's have stuff in your primary real estate zone, close into the worker. And the other picture, which shows the working height of elbow height, when you have precision work, you want it 2 to 4 inches above elbow height, and that's so you can stabilize your forearms when you're doing your work. That's lighter than 2 pounds. Light work, which is less than 10 pounds, is 4 to 6 inches below elbow height or at elbow height. And when you're doing heavy work, you want to have it 6 to 16 inches below elbow height. And again, questions like this were on both the CSP and the CPE exam, this question in particular. How can a seated workstation be improved? One way to do that is with stereo microscopes. So you can see the woman in this position, this posture. She's in upright posture. Her neck is not deviated forward. Her neck is upright. She doesn't have to put her heads right onto the oculars. She can look back a little bit forward. And this microscope picture, the worker has extended oculars and the microscope is on an articulating arm so they can position it as best as they can. And I wanted to go back 1 minute when I said this is on the CSP or the CPE. I meant to say that questions similar to workstation design, precision work, light work, heavy work, and how far in front of the individuals, questions like that are on both the exams. So although this is showing a microscope, it actually highlights lots of the different features with seated workstation. Some type of padded forearm support or elbow support, rounded edges, adjustable workstation height or adjustable chair so you can get that distance right between how high the person's hands have to be off the surface or how high the workpiece, here it's the microscope, needs to be above the surface so that the worker doesn't have to deviate their wrist. Sit to stand workstations are always encouraged. And here's some other cutout workstations, ways in which you can get your torso close to your workpiece, but then have a wraparound area for your forearms. So we moved from sitting to standing. And if you take a long look at this picture, you'll see that taking a load off isn't necessarily the best thing for you to do. Um, you put a lot more pressure on your lower back when you're in your seated position than when you're in your standing position. I talk a lot more about the spine and spinal work-related musculoskeletal disorders and the little in brief on anatomy and physiology, but I thought I'd explain to it here as we're talking about the standing and the seated posture. So here's your spine. Your ears are over your shoulders are over your hips. When you're in this neutral position, you have that nice natural curvature of the spine. The spinal discs, the forces are being distributed evenly from front to back and side to side. So we're in our standing posture, we have the least amount of force on our lower back. And we have kind of this S shape here in our lower back. When we're in a seated posture, what happens is our pelvis rolls forward and we lose that curvature in the lower back. The vertebrae pinch forward on the front, sending the gelatinous material or the spinal disc material towards the back, which can cause compression on some of our nerves. So if this is your sciatica, here's your L5, L4, L3, L2, and L1. And you can see how this entire area flattens out, puts significant amount of pressure in it when you're in your seated posture, as opposed to being in your standing posture and having the forces distributed more evenly. Sit to stand workstations are one of the best ways to keep people from static loading a certain part of the body or a certain muscle joint. It also enables blood flow, increases circulation, and aids in the healing of any soft tissue. And here's some examples of sit-to-stand workstations. The picture up at the top here shows a workstation that was set to the standing height, but you have a chair high enough to reach that, so you can sit or stand without changing the height of the desk. Although I don't really like the keyboard tray as much as just having the keyboard on a desk because it moves you away from your real estate area, which you need. It still generally shows the idea. And here's some more industrial applications of sit-to-stand workstation. These people were repairing engines on aircrafts, and it was just movable legs that you're able to use, or movable workhorses is the term that we used in the Navy. So some standing guidelines. Standing is preferred when you don't have enough knee clearance for a seated operation, so somebody would have to turn sideways. Here's another example of a standing workstation that was used in a repair facility, and the work is being oriented towards the worker. Standing is also preferred when you have high downward forces, such as you're assembling something, or here's a picture of a person who's kneading bread. You wouldn't want to knead bread at elbow height. Instead, you'd want to be 6 to 16 inches below elbow height, so you can throw the weight of your body into what you're doing, or throw your torso weight into it. Standing is also preferred when people have high, low, or extended reaches, which is more difficult from a seated position because you can't use your larger core muscles to stabilize yourselves. Some of the downsides to standing for long periods of time are pooling of blood in the lower extremities, because the way the dirty blood or the venous blood gets back to the heart is through the opening and closing of your valves in your veins, your vein valves. And if you stand for long periods of time and you don't move, that restricts that, as well as if you're sitting for long periods of time. Also, lower back strain. It really depends on the types of shoes that folks wear. Can help to support the feet and the hips and reduce some of that lower back pain. So some solutions are a footrest, or something that allows people to prop a foot up. You can change the pressure on each leg, as well as use different muscle groups, which is what we're trying to do in ergonomics, is distribute the forces, the repetition, the compression throughout the body instead of focusing it on one part of the body. Anti-fatigue matting does work well in areas, provides a cushion so that you have that sway back and forth on your feet in a softer shoe versus a hard shoe or a hard floor where you don't sway as much because it's not soft. It helps to increase circulation. Mats, like you see here, can become problematic when they break down or if they're exposed to chemicals. They don't work so well in areas where you have carts that have to go on top of them, but for standing areas, mats work well. And any type of support sock or support pantyhose also helps with venous pooling. It can be quite dangerous. I mean, there's people who have passed away from um, having blood clots travel to different parts of their body. So leaning workstations, I really like leaning workstations. Enables you to just support some of your weight so you lean back on a chair. You basically keep the same standing eye height. Because you're not completely sitting down, you can still stabilize your body with your core muscles. It's good for repetitive operations. If people have to get up and get down frequently, you don't have to sit all the way down. You can just lean back. Definitely reduces pressure on the lower back and the legs. And this is good for areas, you may have seen them in larger airports where people have to um, still keep the same eye height with somebody. So, for example, maybe in a bank or in an airport, like I said, where you want to keep the same height that somebody who's standing at, although give people the opportunity to sit for periods of time. Or not really sit, just lean back. So again, our workstation, our work pieces, this employee is maintaining the propeller on a hovercraft. It weighs over 900 pounds. When it's brought in on the fork truck, it was placed on the ground. And what they have to do is sand or use a rasp to remove the epoxy on the outside of the blade so they can resurface it. And the solution that we were able to put into place was this fixture that rotates 360 degrees so that it can bring the propeller up to the working height of the individual. It can be in all the different orientations, whether it needs to be horizontal or vertical. And it helps position that into a better posture than what you see here, compression, laying down on the ground, not a whole bunch of opportunity to use your larger muscles to stabilize yourself, especially if you're trying to apply upward forces in this position. Somewhat expensive solution, but it was a solution that we were able to, of course, share across other facilities that do similar work. So you pay the money up front, but then it gets shared. And really increased the quality of the workpiece as well. And a lot of times that is the way that you sell ergonomics to your company, that we are going to spend some money, but we're going to decrease injuries and suffering and increase productivity. It shows all the different ways that ergonomics can make improvements in the workplace. So work surface heights, you can have an adjustable work surface, you can have an adjustable work piece, or sometimes you can adjust the worker themselves. So designing from the point of the hands is important whether you're in a seated position or a standing position. So here we have adjusting the work piece. Here we have adjusting the work surface height, which then again adjusts the work piece, and adjusting the worker. So if the workstation cannot be adjusted or it's not feasible to have an adjustable workstation, one way to do to accommodate people of different heights is to accommodate the tallest person, and then for the shorter individuals we can put them on platforms of some type, or you can accommodate the shortest person for standing, and for the taller person potentially have them in a chair. So some guidelines, I know I had these guidelines up there before, but I'm putting them up one more time to show the different heights given the work that you're doing, whether it's precision work, light work, or heavy work, and where you would like their hands positioned relative to their elbow height, because we're always designing from the point of the hands. And one more time, this was important information That was on both the CSP and the CIH when we looked at ergonomic design. So some general overall workstation guidelines, not if it's seating or sitting, but just to look at it overall. Design from the working point of the hands, orient the work towards the workers. Parts should be presented upright, facing forward, so that people don't have to flip them over or reach to look for them. Avoid extended reaches, allow for several different working postures. Design for a small woman's reach and a large man's fit. Make sure that the feet are properly supported and they're not dangling. Footrests can be useful for standing workstations. I don't encourage them so much in sitting workstations. A lot of times they come in contact with the front of the chair and it creates more of an issue. And one last picture of our workstation being our work piece. This was in, I can't remember. It was in Georgia. I can't remember the name of the location in Georgia. I'm sorry about that. But the people were doing repair work, fiberglass repair work on these small crafts, and they were able to design a boat rotisserie, is what they called it, which really improved the quality of the work, also the productivity, and got people in definitely more neutral positions, happier workers. And that's all I have for you today. These are our new chicks that arrived just a few days ago. Have a wonderful day, and please email me or contact me with questions. Thank you for listening.